Hello, boys and girls, and welcome to our next episode of me trying to teach math from my basement. Yeah, I guess that's the best I can do at the moment. So I want to get into some basic ideas about fractions. What does a fraction even mean? And then how do I convert or rename fractions? Okay, so I already have this number up here, 1/2. In its simplest form, what does 1/2 even mean? This little fraction bar here, that line between the 1 and the 2, really just means divided by. So it really means one thing or one set of things divided into two equal pieces. Okay? We typically think of it just with one box. Well, let's say this was a candy bar that my friend and I were going to split with each other. And we want to be nice and fair, right? Because sharing is caring. Okay? So we split this in half. I get this piece over here, and they get this piece over there. We both got 1/2 of the candy bar. One thing that's important to notice, and that's why I drew this sort of extra circles over here. Let's say we were ordering pizza, and I order a large pizza, and you order a small pizza. Okay? I eat half of this big pizza. I ate half of that whole big pizza. You ate a half of this small little pizza. Okay? You can clearly tell we did not have the same amount of food. My half was much bigger, okay, because my pizza that I started with was larger. That's why you can tell I took my time and I really made these drawings out as good as I could. Right? Another way to do this is to think of it with a set. When I have a set of objects, I can also still split things in half. So now, again, pretend this one is out of the picture for a minute. And then think about the set of 6. I want to split that in half. Okay? A fraction isn't always a small amount. Okay? I want to take 6 and split it in half. Right, we have 6 pieces of candy. Instead of trying to rip each piece of candy up and say, you get this half of the chocolate, I get this half, it'd be all messy all over our hands. You'd be fighting saying your piece is bigger than mine, whatever it is. And a much easier way to do that mathematically is to actually just multiply. We're going to take our 6 things and we're going to divide them by 2. 6 times 1 made the 6, and then the 2 just stays in the bottom. Okay? And it's basically just 6 divided by 2. Now, the easier way to do this would just be to say, I get these 3 pieces, and you get these 3 whole pieces of candy. Because 6 divided by 2 is 3. So that makes that a lot easier to figure out. Okay, so fractions don't always mean a small amount of something. Like if we split $100 in half, we would each get $50. Okay? And you can also kind of do that with odd numbers a little harder, which I'll show you in a minute. So now in our next example, let's pretend that you and I are going to the store. We want to buy, some chips, maybe a drink each. And we have $7 to spend. Okay? How much can each of us spend? It's a little harder with an odd number. 6 was nice because we both got the same amount. Well, we'll still get the same amount, but I'll show you kind of what to do with that after. So again, we have our $7. That's our set. And we're splitting it equally into 2 pieces. We really are just doing, like I said, 7 divided by 2. And just like up here, that's still that same math that's already up here. So I didn't erase that part. We're each going to get 3 whole dollars. That was our $6, our even number that we could split. And that 6 goes here, and then we subtract, and we have 1 left over. Now, before, we called this 3 remainder 1. But if I'm talking to a carpenter or something, I can't say I want the piece of wood to be 3 remainder 1 long. That's not an actual measurement. Okay? I can't say, oh, we're baking. How much do I need? Oh, you need 4 remainder 3 cups. Well, I don't know what that means. Or 4 remainder 3 pounds. That's not an actual measurement. So all that happens, all that changes, is that 7 divided by 2, that 3 remainder 1, this becomes our big number, or our whole number. We each got 3 whole dollars. And that remainder of 1 becomes our new numerator, or our new top number. And then our bottom number just stays the same. 2 was on the bottom. That was also that number here. And we call that 3.5. We each got $3.5. Or in my money example, that'd be $3.50. Okay, let's think of that same idea down here with 2/3. Again, you're thinking about 2/3. We're used to just that picture of just here's the two pieces colored in out of 3 of them. Okay, use another good word problem. Say every day during math, mom or dad, grandma, aunt, uncle, whoever you're with, tells you got to work on math for an hour each day. Okay? And the Google Classroom part takes you about 40 minutes. That's 2/3 of an hour. So again, on Monday, you were on Google Classroom doing math for 2/3 of an hour. On Tuesday, same thing. Wednesday again. TH for Thursday. And then again, this was Friday. And you want to know how much time you spent just on that Google Classroom part. Maybe that other 20 minutes every day, you're on Prodigy or MobiMax or something like that. Okay, but just say you do 40 minutes every day on Google Classroom. We did that for 5 straight days. That's 5 times 2/3. And again, when we have this example here, we just times by the top only. 5 times 2. If you count it up, there would be 10 pieces there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it still takes 3 pieces to make 1 whole hour there. And then we just do our same division again. What is 10 divided by 3? And again, we'd end up with 3 whole hours and then 1/3 of an hour left over. Or I should start it first. We call it 3 remainder 1, and then convert to 3 1/3. Okay, that's kind of that improper fraction over here, 10/3. That's that improper version of that. 3 1/3, we call that the mixed number. It's a mixture of both whole numbers, 3, and fractions, 1/3. This is called the improper, meaning not proper fraction. Excuse my writing. I'm trying to go quick and squeeze it in. That's an E, improper. All right, so again, I'll give you kind of one more example in a minute. I'm just going to set it up and move the camera. So I know this video is getting a little longer, but it's a really important part. Okay, I have another example here. So every day, again, mom or dad or someone at home is making kind of a protein shake. And the recipe calls for 3/8 pounds of some kind of mixed berry that they need in a bag. So mom and dad are trying to figure out, well, how much am I going to need of that for this week to be able to do 3/8 of a pound each day? So every day, again, they're going to do 3 of each of those. All right, so it's Monday, Tuesday, Wednesday, Thursday, Friday, and then also on Saturday and Sunday. And that's kind of the first week of their training regimen. So they really just did 7 days. Each day, use 3/8 pounds of those mixed berries. So again, in the blender and with all the other stuff. So again, you just do that big number times the top. 7 times 3 makes 21. And then we have that over 8, our same bottom number. So I wanted to give you kind of a different example here, one that didn't have 1 as a remainder. How many times can 8 fit into 21? Think about my math facts, 8, 16, 24, up too big. So I don't have 3 whole pounds. The closest I can get is 2 whole pounds. That just means 8 goes into 21 2 whole times. I'll use a darker marker because the green is kind of hard to see. And I have 2 whole pounds. And then what was left over would be 21 minus that 16, which is that 8 times 2, which is 5. So I have 5 as my remainder over 8. Again, and all you do to go backwards, you just do the other way. So you notice whenever we went from an improper, which is the 21 over 8, to the mixed number, 2 5/8, we always divide and then subtract. Again, I keep using that green. It keeps not showing up. We divide and then subtract. When we go in the other direction, we want to use the inverse, kind of like reverse, go the other way. So what's the opposite of divide and subtract? Kind of feel like Dora the Explorer right now, like I'm talking to no one. Okay? That's right, Boots. The opposite of divide is multiply. The opposite of subtract is add. So I multiply this way, 8 times 2, and then I add the 5 on. 8 times 2 makes that 16. And then 16 plus 5 gets me back to that 21. Same thing would happen with 3 1/3. 3 times 3 makes 9, plus the 1 is 10. That's just my new top number. That's how I got back to 10/3. Or same thing with 7/2 to 3.5. 2 times 3 makes my 6, plus the 1 gets me back to 7. Okay, so kind of a cool little thing. This is a long video. You guys did an awesome job, and I hope this helps. And I will be back to do another. I'm going to try to use those same pictures for adding and subtracting.